Bismillahirrahmanirrahim. Let we start another subtopic under module 5. Okay, for this video is under module 5. We're going to look into a new things we didn't touch or learn before. It is a dual symbol. What is the meaning by dual symbol? So here is the example of dual symbol. When you have Nand Gate, Nand Gate is basically similar to OR gate, but you are having the negative in front. So alternate of this Nand Gate is a symbol of this one is alternate symbol for your Nand. This is a negative OR. Nand Gate is similar to negative OR. What is negative OR? Which is you are having the OR gate, but you are having the negativity, or we call as a bar. And when you put the circle there, over there, like this, you put in front. When you have the OR gate, you put bubble in front, it called as a negative OR. Remember back at our early class, if it is bubble, it is called as a negative or an inverse or a not, a bar, which is similar. And another dual symbol is for NOR gate representation. You can have the alternate symbol for a NOR gate similar to the negative, and you can see here, this is negative n. So how you going to do the conversions of alternate symbol? You can follow this step. Okay, in this example, you are having the NAND gate, and then you have another one is supposedly it is a AND OR logic, isn't it? So supposedly it is a OR there, you can see, but instead of just OR, you want it to be a negative OR. So negative OR, if you have AND OR, you put negative in front of the OR. So you need to put, after the AND gate here, you put another bubble. Why you need to put these two? Because this inverse we cancel to each other. That is the first step. Second, after you put the bubble like this, you need to put bar. When you have like this, right? So you cancel to each other. You can see it is the purpose later on to cancel each other, like you are putting a 0 in there. So for this example number B, bubble cancel a bar. You can see it will cancel a bar, which is you will get A, B, C, which is similar. Then when you have the D here, example number B, you are meeting the bubble, you're going to put the bar like this. So be careful. This one I already mentioned last time. Okay. Dot. D dot E is not equal to D bar plus E bar. This is the hint. So it is not equal to, because this one is off, D dot E. And next subtopic is you need to convert your SOP circuit. Whatever your SOP circuit, please remember back, which is you are having the NO logic. So we call it as a SOP circuit. Then you need to convert it to be Nand Gate only. So you need to use Nand Gate only. So I already mentioned is sometimes when you are shorted in where whatever gates that needed, so you can use another gates, but you need to like combine, you need to construct following their methods of circuit. So you need to put the bubble at the input of the AND gate and the at the output for the AND gate and the input for the OR to be a negative OR. Now this one is already become the NAND gate. So for this part, when you have a negative OR, it's similar to, go back here. If you have this negative OR, it is similar to the NAND gate. So when I already put here, I have this one, so that's why it can be represented as the NAND gate. So first step, you put the bubble. Second step, you need to change and replace the OR gate to be the NAND symbol. So this is the answer. Okay, just now you are having the SOP, which is AND OR logic. But how for you to having the POS? So by using converting POS circuit to NO only. This one, when you are having the POS, you need to convert to the OR gate only. So first, you were given this one, POS circuit. You have the OR gate and then AND gate. What you need to do, first you need to put the bubble that can cancel each other, which is not going to affect your circuit. Second, you need to effect of the putting bubble, add another bubble, output. Okay, this one is already full in already with the bubble things. Then you need to replace this one, will be a NO gate. Refer back to the beginning slide here. When you have the negative AND gate, you will get the NO gate there. This is similar to this one. Okay. So there is a possibilities for you to have only NAND gate and then only NO gate. So it's called as a dual symbol. This one. Dual symbol is needed to simplify the reading of schematic, which is can determine how the circuit works, and it's very fast. You can see dual symbol, you put the bubble there. And in this subtopic for your dual symbol, you need to see on the odd and even level. How to check the odd and even? So before you go for odd and even, you can see dual symbol is needed to simplify the reading of schematic. If you are using the Nand Gate only, this one is the scenario for you to having only Nand Gate. Replace the Nand Gate, which is you have the old Nand Gate, with the dual symbol, which is the negative O. Choose the level that you want to replace the alternate symbol, which is whether it is odd or even. If you choose odd, only replace the odd level. If you like maybe later on if you are using only even, so you need to only replace the even with the alternate symbol. So this is odd, this is odd, this is even, this is even. How to determine your circuit level? So this is your even, this is odd, even, odd. If let's say in this question what odd okay, in this question if let's say you are referring to odd levels, you need to change only this, but you need to represent in terms of the dual symbol. So you change this Nand Gate to be the bubble O there. You can see? Check back at the first slide there. If you have the what else just now? What is just now? I guess let me double check. Wait. Okay, this one is Nand Gate. So look back at the Nand Gate you are having here. For the Nand Gate is similar to your negative O. So you need to replace with your negative O. So you replace with the negative O for this part. Okay, this part odd, odd. So this you change to be the negative O. Here also negative O. Then you can see after that, when you have this, your output expression can be obtained directly from the function of each gate symbols in the diagram. So this is the output, which is basically similar if you solve it using your old Nand Gate. Similar to each other. Okay, this one example. You can see redraw the logic circuit. It's already mentioned. You can see odd level. So you need to only change or effect on your odd level using the dual symbol. Whether this one is Nand only, right? So you need to change it to be the negative O. So first you can see here is your odd level, and then your even, and then is odd. So this part you need to change, this part also you need to change. From here you will having the negative O. This one you have the negative O. This is also a negative O there. And you have the final answer, but this is the redrawing that it asks you to do for the dual symbol. Another example, redraw the logic diagram for the even level. This is odd, this is even, this is odd. So only even. So where is it? This part. You need to change it to be negative or. So you change this one. You can see it's changing this part. And there is another one. And this is the expressions of x. It basically similar to this expression of this logic circuit. So that is on how you will get the final circuit and also the expression. Done with your Nand Gate. Now dual symbol for you to look into if you have the cases of no gates only for your logic circuit. So you can see here, this is all no. This is odd, even, odd, even. So it's depend on the question. If it asks on the odd, so you need to change this, and then you need to change this to be the negative AND gate. Negative AND gate. And you can get a similar answer. Okay, here there is example. You need to use only the NOR gate. Express it using a dual symbol. So it asks you to use the dual symbol. When you have like this, you have A plus B. This is A plus B. You have C plus D. And you multiply it together. Supposedly it's going to be AND gate. Here is supposedly AND gate. Now this AND gate, if it is odd level, you can change it to be negative OR. For this part, you will change it to be the negative AND. The answer is basically similar. This and this is similar because your NOR gate represent similar to your negative AND gate. So you were given with the NOR gates there. You need to only look into the odd level. So this is, you need to change to be the negative AND gate. Here is also negative AND gate, negative AND gate. You will get this view. And try to do all the exercise here. 5.6, redraw the logic diagram. And for even level only, so this part, so you change it to be the negative. Then you get the final answer like this one. That is on the NAND gate, NOR gate, dual symbol. So after you learn all of that, you need to know on the designing combination circuit and derive the Boolean expression. So So we're going to continue this subtopic in next video. Okay, so before I guess okay, I will continue with another new video. So thank you for your watching and stay safe. Bye bye.